Hello friends, welcome to module 3. Today we will talk about instrumentation in echocardiography. So this is the equipment, and as you can see, it includes several parts. Of course, main thing is the echocardiographic machine, but on the right side here you see these are the transducer probes that are available. Then here there is a place where you keep the gel for the machine for the transducer probes. Then there are some printing sheets, some contrast material, and sometimes what you also need is a pharmacological stressors may be required, contrast agents may be required. So those are some of the hardware that are required to perform a echocardiogram. Now, what are the parts of the echo machine? So the main part is the echocardiographic probe. So if you look here, this is the transducer probe. So this is the transducer probe which you apply to the chest wall to get the image. So this is, I think, one of the most important thing. Rest of the thing is the CPU unit or central processing unit, which not only gives the electrical current to develop the ultrasound waves, but also acts as a receiver and then transmit to the central processing unit which generates the image. Then there are several controls which are here. So these controls can control the transducer various specifications like the transducer amplitude, the frequency, the duration of the pulse, which can be emitted from the transducer probe. So here are the basically the controls for the transducer. Then there is a display, and here is the display which can display the image. Then there is a keyboard inside it. You will notice that there is a keyboard where you can type certain things, you can type the report and so on and so forth. Also you can take some measurements even on the display and on the print. And then there are disk storage devices which can store the image, and there is a printer where you can print this stored image as well. So these 7 parts are parts of the echo machine, and we will show you exactly in a echo machine, but I've already shown you on the photo that is available all the different parts of the echo machine: transducer probe, the CPU, the transducer probe controls or the control, the display, the keyboard, the disk storage device, and the printer. So so basically now we need to understand how the echo works. So as I said, in the machine, also along with the machine, there is also some gel. So you apply the gel to the chest, and we are here talking about transthoracic echo. So you apply gel to the chest wall, and then on the gel you apply the probe, and the probe or the transducer, it sends the sound waves into the chest wall, and then these sent waves basically hit the various structures in the heart and they get reflected back. So here you can see that it can get reflected back. Ultimately these reflected sound waves will be converted into electrical energy. Electrical energy will be processed by the central processing unit and it will generate an image. So here is the image, and of course, as you know, this is the probe and this is the gel that has been applied. So this is how the echocardiogram echo machine works. Now coming to the most important part, the transducer probe. So this is a typical transducer probe that you can use in the echo machine, and basically it is responsible both, as I already, and I will talk about in detail how transducer first of all gets electrical energy from the computer or from the machine, and then the transducer converts it into sound waves. These sound waves travel, they strike various structures in the heart, they get reflected back. The transducer probe itself acts as a receiver for these ultrasound waves, and then these ultrasound waves are converted into electrical waves, and then these electrical waves are sent to the CPU where image is generated. Now, so the key element of transducer probe is something called a piezoelectric crystal. So, what is piezoelectric crystal? It is composed of a material called barium titanate. And what is the property of barium titanate? The property is that when you apply an alternating current to it, it expands and then relaxes, expands, relaxes. So basically, there are many crystals arranged in a row, and I will show you exactly how it is arranged. So maybe 2, 3, 4 rows. These crystals are arranged. Each crystal is a unit in itself. And when electricity comes to these crystals, they start expanding, contracting, expanding, contracting, and that generates the sound wave. And that sound wave travels. So basically, piezoelectric crystal is the main element of the probe, where electric energy gets converted into sound energy, and then once it strikes the structures, comes back, it is again collected, again goes to these piezoelectric crystals, which convert sound waves into electrical energy again, and this electrical energy again goes back, and this happens. So this is basically, as you can see, this is the ultrasound machine, and what it does is, on the probe, it generates these sound waves. So the sound waves are traveling. These are the structures of the heart. It strikes the structures of the heart, and then it gets reflected back. So the sound wave gets reflected back, again picked by the probe, which is the part of ultrasound machine, and then the whole process starts. So this is the way this particular thing works. And I already elucidated the mechanism of action. Basically, we are talking of a linear probe, and here basically, again, because this is very important to understand, that when the electric current is applied to the crystals, they start vibrating, they generate sound waves. These sound waves go and to the various parts of the body, in this case heart, and basically strike different structures of the heart, get reflected back, bounced back, and then they basically reach the piezoelectric current inside the probe again, where they are collected and converted into electrical energy, and this electrical energy goes to the front end processor, and which sends them to the CPU. And now important thing is that, as you might see, that sound is, if it is emitted back, it can get emitted in it can get emitted and strike from different parts. But what it's done is that they apply a insulation here. So this is the insulation which prevents sound from here entering the piezoelectric crystal. So sound from here cannot enter the piezo. Here, on the other hand, there is a lens kind of thing which absorbs the sound and directs. So sound only strikes the piezoelectric crystal in this direction. It cannot in this direction, it cannot in this direction. Only linearly it can pick up the sound, and therefore there is objectivity into what all is happening. To again look at the transducer structure, here you can see that these are the piezoelectric crystals, and you can see they are arranged in, here there is only one row, but normally 2 or even 3 rows of piezoelectric crystals are there, and this is the where the alternating current is applied. So you can see each piezoelectric crystal is connected by a separate circuit. So every piezoelectric crystal has its own circuit through which it generates the sound waves, and also later on again transmits the sound wave into and converts into the electric current. So you can see each crystal has its own circuit. Every crystal, you will see, has its own circuit like this, and this is that. Then here what is there is a matching layer, and basically there is a absorbent lens placed here, and here is the insulator. So you can see this is the this is all is insulator. So sound waves cannot reach the piezoelectric crystal from this direction. It can only reach the piezoelectric crystal from the in a linear fashion. And here you can see is the power supply. So insulator, piezoelectric crystal, various alternating current reaching here, and then by several circuits. If there are 100 piezoelectric crystals, there will be 100 circuits, individual circuits, and each individual circuit taking electricity directly to the piezoelectric crystal. So this is how the probes look, and inside it, as you already know the structure, there will be a piezoelectric crystal, there will be a acoustic insulation, there will be a lens positioned in front of it, which will also allow a good transmission. So everything will be there in the probe, but probes come in different shapes, and as you can see, they are different shapes, and also different types of probes are there. So there can be a linear probe which only gives linear energy. There could be a semicircular probe, or you can say a curvilinear probe. But most common, at least that is used in echo machine, is called a phased array probe. So I think that is the one that you need to know. The phased array is the main probe that is available for echo application. In other ultrasounds, they may have curvilinear probe, they might even have linear probe. But in echocardiogram, which is a very specialized kind of ultrasound machine, the probe that we have is normally a phased array. So now, what are the things that determine? So number one is the shape of the probe. So depending on the shape of the probe, you can access some part. If you want to access only a narrow part, then you can have a probe which is a very narrow probe. But if you have a wider probe, then you will access a wider part. The important thing of the probe is, depending on the electricity that is coming, the frequency with which the electricity is converted will get converted into a frequency of sound waves. So if you can control what kind of electricity is coming to your transducer probe, you can also control the frequency, and frequency decides how much part of heart you can access. If you generate high frequency ultrasound waves, then you can penetrate deeper, you can reach deeper layer of the heart. But if you have short wave frequency, then you can only see superficial parts. So depending on what part you want to see, you can change the frequency of your probe. You cannot change the shape of your probe, but you can certainly change the frequency of the probe. And as I already discussed with you, there are more than one layer of piezoelectric crystals, actually many rows. And in the, I think, previous view, you would have seen that there are many rows of piezoelectric crystals. I will show you later as well. And each of them has its individual circuit. So I think that is important to understand. And you can use this probe to move across the chest and look at different parts. So here are these types of probes that are there. Important thing is that in our kind of probe, the beauty of phased array is that with even a lower frequency, you can achieve a depth. So with even 1 megahertz of frequency, you could reach a depth of 35 centimeter. But with linear probe, even with 10, you might reach only 9 centimeter. So because heart is a deep seated structure, you have to cross the whole chest wall to reach heart. So that is why you require a phased array probe. Phased array probe is also useful when you want to look at lungs, pleura, or deeper structures of abdomen which are situated deeper. Than a phased array probe is useful. So this is a special type of probe. So wherever there is increased depth, a phased array probe is useful, and therefore it is useful in cardiac echocardiogram. Now, what is the effect of the probe position and probe angle? And this is an example of transesophageal echo, which is actually the other type of echo, which is the probe is ingested by the patient and then it goes behind the esophagus. Depending on where in esophagus you are and depending at what angle you place the transducer probe, you can view different parts. So you can see in this particular slide, you can see various parts of the posterior of the heart that can be seen depending on where you position the probe and how you angulate it. So this is another example of transducer probe position. So you can see upper esophageal location will view something else, mid esophageal, transgastric, and even deep transgastric. So you can view different parts depending on what part lies immediately in contact with that part of the esophagus. You could access different parts. Likewise, where you apply the probe on chest, you can access different parts of the heart also. So same thing happens when you apply on the chest also. So transducer or probe position is very, very important for accessing or viewing the heart structures. Now coming to the second important part, which you can call, if probe is the heart of the ultrasound, then CPU is the brain of echo machine. So CPU, you can call it as a brain, because what it does is it contains a microprocessor, it contains memory, it contains amplifiers, it contains the proper power supply, the microprocessor and the transducer probe. So all these things are present in this central processing unit. And what central processing unit does, again, it sends the electric current to the probe, and then probe converts into sound wave, etc., as you already know, and then it again receives the electrical pulses. And after receiving the pulses, these electrical signals, which are then sent to the processing unit, and where basically the CPU does all the calculation, processes the raw data, and once raw data is processed, the CPU forms an image that you very well see on the monitor. So this is how the whole thing works. Later on, the image in the monitor, you could even store it, keep it as a processed data, or you could store the image on the disk as well. So here are the transducer probes, and you can see that these are the transducer probe controls, because as I said, transducer is controlled by this particular transducer control, and you can see there are many things here. And so this is one which looks at depth. This one either reverses the image. This part is the probe holder. Here will be some place where you can put in the probe. So this is the probe holder, you can see. And then this part, you can see it is gain key, and you can shift various modes. Last time I told you there are various modes. There could be a B mode, there could be a B mode, there could be a M mode, there can be a pulse Doppler, there could be a continuous wave Doppler, and finally there could be a color Doppler. All these adjustments are made through this particular switch, where you can make different types of connections. Then the other thing is that there are some other additional features. Here you can see this particular control. Here you can shift to 3D basically viewing. If your computer has that facility, you could even shift to contrast harmonics. So these are the things. Then this is the keyboard that I was talking about, and we will come back to it. Through here you can type the report, or you can basically make certain calculations. You can note down the calculations. Everything you can do on this keyboard. Then this is the audio volume. So if you want to record a video while the image is playing, you can want to say something, then you can do it. There is a video VCR here, and then there is this another side for transducer holder. This is the place where the gel is stored. So two gels are kept. You can see the gels are kept. Then this is the touch button brightness. So you can increase the brightness, you could decrease the brightness. Finally, coming to this very important part, which is the touch screen. So this is the touch panel. This is the touch panel. This is the touch panel. In the touch panel, there are various kind of things that you can do. You can optimize. There is a power control, there is a frequency, there are harmonics, there is a dynamic range, the dynamic range, zoom, wide zoom, then read zoom, focus, rejection, suppression, frame averages, edge enhancement, colorize, gray map, rotation, reverse multi-image, edge enhancement, sweep speed, display mode, and multi-image. So many things are present on the touch screen as well. And as you can see, touch screen is a very important part of the control for the transducer. Now, going to the specific parts of transducer control, this is the transducer gain control. And what is the gain control? You know that at deeper parts the reflection is poorer, so image quality of deeper structures may be poorer than the proximal or those structures which are present superficially. So how to control that? How to make sure that all part of the heart looks same? So for example, if you look at a statue, then upper part of the statue will look smaller versus the lower part. Likewise, if you use this ultrasound probe, then the distal part or the structures present at depth will look weaker, and the structures that are present superficially will look bright. So to control that, this particular transducer pulse control setting are there. This is the gain setting. So this is the transducer gain control, and you can through it change the frequency of the ultrasound pulse. So if you're looking at the proximal structure, you can keep a lower frequency, but if you are looking at distal structure, you might have to increase the frequency. And that is how you can change the brightness of different parts of the heart. And this is of course the echo display. As you know, this is the echo display. It is like any other computer. It takes data that CPU has already analyzed and formed an image. It shows that image here, and you could analyze this image, and you could even change the part and see a different image. So this is the display of the thing. Then again, coming back to the keyboard with control knobs. So you, as I already told you, every machine also has a keyboard. So this is the keyboard here, and this is another keyboard. You can see this is the keyboard. So keyboard's function is to enter information and data into the computer, such as patient's name, height, weight, why, the indication, and then other information is fed. And basically control knobs can also help you to change the image on the screen, to make it more sharper or make it bit dull, depending on what you want. So all this can be even done by the keyboard. Then of course there is a echo printer, and as I said, once you form the image, it is possible to make a hard copy of the image, and basically you can use it for giving it to the patient, or on follow-up also. You can look at the previous images and you can compare with the new images, and when they can make a basically take an opinion on what has happened. Also nowadays thermal printers are also present, which are very good. Now display, I already showed you. Every screen will have a display, and you can look at, it could be either a colored display or a black and white, depending on what kind of machine you have and what kind of programs you are using. It can be both ways. Then of course, at least in the previous machines, there was this small CD which you could insert and store your data as digital video discs. You could make DVDs, and you could have compact discs, you could have floppy disks, you could have hard disks. So this is the place where you can basically store, and then it can be exchanged, or it can be given to the patient, or it can be even accessed by another doctor in his own machine. Hard data will of course remain in the machine itself, but this data can be transmitted to patients. Now I think the most important thing to know in echocardiography, or the basic thing to know in echocardiography, how to adjust these settings. So I told you there are many settings on the echo machine. I showed you those settings. We will also show you them on directly on the echo machine also. But how to use these settings is very important. The difference between a successful echocardiography and a failed echocardiography is the proper adjustment of the settings. If you can properly adjust the settings, then you will get a very good picture. But if you are unable to set, then this will be a problem, and you might get a poor quality image, and you may not be able to make the diagnosis. So important thing is to know these settings, and I will again show you these settings because this is very important. The important settings are power output, of course. Without power you cannot do anything. Then time gain compensation, I showed you the time gain compensation. Then there is a setting of a depth, where whatever depth you want to access, you can direct your echo images on that depth. Then whatever sector you want to see, you can arrange it to look at that particular sector only. And then you could have, if very deep structures are there, very difficult, then you could even compress it so that you can see. Or if it is a very large volume of material that you want to see, you could compress it to make it smaller, and then able to see. And then of course there are settings for focusing. So these are the settings that you need to know in any echo machine, and I will show you how to take care of them one by one.